All right, let's take a look at this example as well. We have this diagram talking about a metal, a block metal with a hole of diameter 7 centimeters inside it. We have to calculate the mass of the solid if the density of the metal is 7.9 grams per centimeter cube. So I'm going to start my solution right from here and begin to explain how to solve that. Now, to solve this example, the first thing we need to put out there is the fact that, okay, so this is question A, we're trying to solve now, is the fact that the density formula is given as mass over volume. Mass over volume. We have to calculate mass so we can easily cross multiply again. And when we cross multiply, we're going to have mass to be equal to density times volume. Density times volume. But something is missing for us to find this mass. The density is given in the question, 7.9 grams per centimeter cubed, but the volume is not given. So we have to find the volume. So very important, we must find the volume. Okay? Now, to find volume, what we're going to have is the fact that the volume of metal is going to be equal to the volume, for short, VOL, of cuboid, because we have the shape to be a cuboid based on the dimension, minus the volume of the hole inside it. And the hole inside it forms a solid shape that you know as a cylinder. If you are wondering how that hole forms a cylinder, when you imagine a hole inside a block like this, you will expect that at least at the end of it, okay, at the end of it, it will go like that. And the hole will show, okay, as I'm showing you now, it will show on the other end, on the other face of the cuboid when you have a hole inside it. So what the hole is forming inside the cuboid is a cylinder, as you can see it now. So that is how we know that we have to subtract the volume of cylinder, which is the hole that was removed from the metal box. We subtract it from the volume of the entire cuboid. So again, you have to quickly remind yourself about the formula of cuboid and also of the cylinder. A quick one. The volume of cuboid is still your length times breadth times height. Minus the volume of cylinder is pi r squared h, which simply means that you need the radius of the cylinder and you need the height of the cylinder. If you take a look at that diagram, you will observe that the height of the cylinder is going to be the same length for your cuboid. So that from here to here, if I pick on, use the green pen to show that, from here straight down to here is also 13 centimeters. So that is also the height of our cylinder inside that cuboid. So take note. So this is length for cuboid, this is breadth, and this is height that we're going to make use of to calculate our answer. So moving on that and trying to substitute values, I'm going to have the length is 13, so I have 13 centimeters multiplied by 9 centimeters multiplied by 10. That is for the cuboid. Then minus, well, let us take in our question, let's tell ourselves to take the value of pi to be equal to 22/7, so that we know the value of pi we are making use of. So over here, I could open a bracket and have 22/7 multiplied by radius. What is our radius? for the cylinder. If you look at the diagram, you will see that they gave us the diameter of the hole, which is the diameter of the cylinder, as 7 centimeters. And radius, as we know, is expected to be diameter over 2. So you can do your 7 centimeters over 2, you get radius as 3.5 centimeters. Okay, so since radius for the cylinder is 3.5, we can then have 3.5 squared and multiply by the height, which is also 13 centimeters. So to complete this calculation, we're then going to have the following. So multiply your values and get your results. When you do the multiplication, you are going to get this is going to be equal to 1170 minus, and when you do the calculation of your 22 over 7 times 3.5 squared times 13, you should get 500.5. So when you subtract, the final answer should give you 669.5 centimeter cubed. Okay. Now, what you have found is the volume of the metal. And what are we trying to find? We are trying to find the mass of the metal. So conclusively, therefore, the mass of the metal will therefore be equal to density times volume. That's the formula here. So what's your density? Given in the question as 7.9 grams per cm cubed. Okay, so you multiply by the volume, which is 669.5 cm cubed. Of course, you will expect cm cubed to cancel cm cubed out, so that you are simply left with 7.9 grams times 669.5. And that gives a final answer of 5289.05 grams. Okay, if you like, you can leave your answer in kilogram. If you want to leave it in kilogram, you can tell us that this is approximately 5.3 kilograms. After dividing by 1,000, remember guys, 5.3 kilograms, and that answer has been given to 1 decimal place, and that's okay. So that is your answer for the mass of the metal, and that is correct. So let's move on to the next question, which is the B part of the question. The B part of the question talks about something very simple. So I'd like to manage the space so that I can focus on question B. So let me do this again, just like I did in my previous example in the last video. So over here, I can ascertain question B. For question B, we're told that if the solid is melted down and recast as a cone of diameter 8 centimeters, and if during this process none of the metal is lost, calculate the height of the cone. So it's like we just put the metal box, okay, inside the humidifier furnace and we melted it. Now, when you melt it, you will realize that the volume of metal, melted metal, will still be the same, okay, as what will be used to make the cone. So you will expect that in that transition, volume of metal must give you the volume of cone, because it is the metal that was melted down to form the cone. So they must have the same volume. In fact, they will also have the same mass, but since we are looking for the height, using mass will not lead us to finding the height, but volume will help us to find the height. And since the volume will be the same for the cone as well, we can easily equate the volume of cone to the volume of the metal. Volume of metal already calculated as 669.5. So we substitute. Volume of cone, you have to remind yourself the formula. The formula for the volume of cone is 1/3 pi r squared h. H is the height that we are looking for. Pi is given at 22/7. The diameter of the cone that is formed is 8 centimeters, so which makes the radius to be 4 centimeters. Remember, radius is diameter over 2. So if I do that substitution, I'm going to have 669.5, okay, to be equal to 1/3, all right, times 22/7 times 4 squared, since the radius is 4, and then times h, the height. With proper calculations, you are going to have that height to give you a very unique answer. So please perform that calculation and see what you get for the value of h. Definitely, we're going to be expecting h, after making the height the subject, to be equal to 669.5 times 3 times 7. I'm sure you understand what I'm doing here. Just like cross multiplying and multiplying out. And this will be divided by 22 times 16. If you do it well, you should get that. And when you divide, you are going to get this to be equal to 39.94. 39.94 centimeters for that. And we can decide to give ourselves a final approximation, okay, for the height. We can still say that we can then have that to be approximately equal to 40 centimeters. Remember to say that this is approximated to 2 significant figures. And that is the final answer for the height of the cone. I want to believe this is very explanatory and you understand how we have applied the formulas, volume of cone, volume of cylinder, volume of cuboid, to answer this question. So these are examples of how to apply those formulas to solve questions on volumes of solid. We'll still take questions that will also show surface areas, curved surface areas, total surface areas in the next video, okay? So see you in the next video with the next example. All right, see you then.
Mr. Digi.
Yes.